Hey everybody, Mr. Moriarty here. Today we're going to do a mini lesson over scientific notation and the computation and conversion from standard to scientific notation. So, going to try to keep this relatively short and sweet. Here we go. So, what scientific notation is, as you've kind of seen these past couple days, it's any number written as the product, meaning a front number or a front factor um, times 10 raised to some exponent. So it's any number written as the product of a factor and the power of 10. The factor, which is that number in front, must be greater than or equal to 1, and it has to be less than 10. So you'll notice, just kind of looking at these first four examples here, all of the numbers in front of the times 10 to whatever power, they're all somewhere between 1 and 10. That is how you know your first factor is a part of the scientific notation view or whatever form, if you want to call it that. All right. What standard form is, don't look too hard into it, but it's just going to be the way that we normally write numbers. So scientific notation is used for really, really big numbers, typically, really, really big numbers and really, really small numbers. It's just a concise way for us to write those numbers nice and clean. All right. So for writing numbers in standard form, what I would recommend that you do is wherever your decimal is going to be affected by whatever the exponent is. So if you have a positive exponent, we're going to move the decimal to the right. If we have a negative exponent, we're going to move it to the left. So the process that I like to do is I like to write 5.34, right? Just leave it like that. And then I'll take a look at what my exponent is. Since this is positive, that tells me I'm going to move my blue decimal point in the positive direction, which is to the right. I'm going to move it 4 places. 1, 2, 3, 4. And then whatever you get after that, your decimal will end up at the end like that. So this 5.34 times 10 to the fourth is just really 53,400. You can put the decimal at the end, but you don't have to. Typically, I won't. All right. So on the other side of that is if you have something with a negative exponent. So again, knowing that I'm going to move this to the left, I'm going to set my 3.27 a little bit to the right. But in this case, since I have a negative exponent, I'm going to move my decimal to the left. 1, 2, 3. That's where it's going to end up. And then I fill in with zeros. Since this is going to be smaller than 1, I do like to put 0 point and then fill in the rest of that. Okay. So what I'd like for you to do now is pause the video, write these next two, and then we'll go on for standard form to scientific notation. Okay, hopefully you paused the video. If not, I'm going to do these really quickly. So this is 7.42, 1, 2, 3, 4, 5. So this is going to be 742,000, right? For the last one, this is 6.1. We're moving our decimal to the left 2, 1, 2. So this is going to be 0.061. Okay, so that's standard, or that's scientific notation to standard form. The next part we have here is standard form to scientific notation. So you can see that these numbers are really, really big or really, really small. All right. So what I like to do here is I'll copy in blue where the decimals are just so we can compare them. So for this whole number, 3,725,000, the decimal is right here. Where I need it to be for scientific notation is I need it to be moved so that the first number is between between 1 and 10. So that would be location here. All right. So I know that this is going to be 3.6 0.725 times 10 to some power. Where my purple decimal is, I'm going to start from there and move that to where the blue one is. And you'll notice as I do that, I go to the right. 1, 2, 3, 4, 5, 6. So I moved 6 times to the right. So in scientific notation, this would be 3.725 times 10 to the 6. If I did this for a number that was less than 1, so the second one here, my decimal is already in there so you can see it. But where I need it to be for scientific notation is I need it to be between the 3 and the 1. Because when I move to the left this time, 4 places, my 3.16 will be being multiplied. Again, I went to the left 4 places, so it would be to the negative 4th. Okay? Anything smaller than 1 is going to have a negative exponent in scientific notation, and anything larger than 1, I know we have 3 million, which is way large, that's going to be a positive exponent. So pause the video, try these next two, and come back and we can check it. Okay, hopefully you did that. For this first one, again, here's where my decimal currently is. Here is where I need it to be. So in scientific notation, this is going to be 1.414. You don't need the zeros after this. I guess I didn't discuss that on the earlier one, but that's okay. It'll be times 10 to some power. We're moving to the right. 2, 3, 4, 5, 6, 7. So this is 10 to the 7th. On the next one, the last one here, decimal is between these two zeros. For scientific notation, I need it between the 8 and the 7. So this will be 8.76 times 10. I'm moving to the left to the negative 3rd power. Okay? So that's standard notation to scientific notation after we just did scientific to standard. So now we're going to do the computation. And multiplying and dividing are a bit easier than adding or subtracting. You do have to remember your exponent rules, though. So I'll kind of talk about that as we go through them. So the first thing that we need to do when we are multiplying, all of these 4 here is multiplication problems because you have 2 parentheses next to one another. So these are all for multiplication. So for the first one, your first step is going to be you group the constants and the powers separately. So since this is all multiplication, it follows what's called the commutative property, which means that you can switch the order around. It's like saying 3 times 4 is 12, the same way that 4 times 3 is 12. You can switch the order around. It says the same thing. So what I'm going to do first is I'm going to rearrange this. I'm going to say, okay, we've got 7.2 times 1.6. Okay, so those are my factors that don't have the power of 10. And then on the other side of that, I'm going to group my powers of 10, which is 10 to the 3rd times 10 to the 4th. Okay? After you regroup these, you're going to multiply your constants, and you're going to add the exponents of powers, because the rule says when you have the same base and you're multiplying those powers, you can just add them. So what it'll look like is this. I'm going to use a calculator, obviously. So 7.2 times 1.6. We're going to run into an issue. I knew that. Okay. So this is 11.52 times 10 to the 7th power. Now the issue with this is if you were paying attention before, the front number has to be between 1 and 10. 11 is not between 1 and 10. So we're going to do something, and we'll get some more practice with it later in this, but we're going to do something a little crazy. What we need to do is let me do this. We'll be okay. We need to move our decimal back 1. So we need to decrease our decimal by 1. If we decrease our decimal by 1, we're moving it lower in the place value. So what we have to do is we have to increase our exponent of 10 by the same amount. Like I said, we'll get more practice on this later in this. But just to make sure we're still talking about the same number, comparing 100 to 1,000. Like 100 and 1,000 are not the same number, even though they have the same digits within them. So in order to keep this perfectly in scientific notation, we'll set it up like this. So now instead of this being 10 to the 7th, it's going to be 10 to the 8th. Okay? So in scientific notation, this is going to be exactly what I said it was. And then in standard form, you can kind of do this on your own. I'm trying to keep this semi-short here. But you're going to move your decimal to the right 8 places. So that should give us 1, 1, 1, 5, 2, and then 1, 2, 3, 4, 5 zeros. So it should be 115,200,000. Big number, but again, that's the point of scientific notation, is to make big numbers a little bit easier to work with. All right, so we'll do another one. We'll do the one on the right here. It's going to be the same process, though. I'm going to, let's see, make sure the first factor is between 1 and 10. Okay. I'm going to switch the order of these, making sure I get my factors where they need to be. And then my 10 to the 4th comes over here with the 10 to the negative 3rd power. And then I'm going to multiply 2.63 times 1.2. Good, this one's going to work. 3.156. And then again, I'm going to add 4 plus negative 3. And 4 plus negative 3 is actually going to get you just a 1. 4 plus negative 3 is 1. And that's it. We don't have to do the weird moving of the decimal and the changing of the 10's exponent, because this is already in scientific notation. That 3 is between 1 and 10, so we're good. Scientific notation is 3.156 times 10 to the 1st. And then in standard form, we're only going to have to move our decimal 1 to the right, because 10 to the 1st tells us we're going 1 to the right. So in standard form, this would be 31.56. Okay? So again, I want you to pause this video and then come back and try these on your own, and then come back and we'll go over it. Okay, so I'm going to do this probably start to finish, but I am going to try to go quick here. So I'm going to take this 8.4 times the 2.5, and then I'm going to take the 10 squared times 10 to the 6. We're going to add those exponents, but before we do, take the multiplication here. That gives me 21 times 10 to the 8th power. So our decimal is right here for 21, and 21 is larger than 10, so we need to move it actually to here. So in scientific notation, so since we moved this back 1, we have to increase this by 1, just like I did on the one above. So this would be a 2.1 times 10 to the 9th in scientific notation. That extra little step is a little bit confusing. but it is correct. So this is 2.1 times 10 to the ninth. And in standard form, this would be 1 with 6, 7, 8 zeros. All right? That's the first one. Second one, rearrange. This one's another one that we're going to have to switch, I can already tell. So if you take 9.75 times 8.4, you're going to get 81.9 times 10 to the negative third power, right? But again, this is not in scientific notation. We need to decrease our decimal by 1, which means we increase our exponent by 1. So this will then be 8.19 times 10 to the negative 3 plus 1 is negative 2. And in standard form, it would be 0.120819. Okay? So that's multiplying. Okay? Now we've got division, which is on the other side. Division works a little bit easier. We still might have to do that same thing where we move the decimal left or right. But all you're going to do here for division, you're going to divide the constants. So you'll need a calculator, obviously. And then you're going to subtract the exponents of the tens. So what I like to do is I like to separate this into 7 over 3 times 10 to the ninth over 10 to the eighth. And the reason I like doing that is because when you take 7 divided by 3, that's going to give you 2.33. It's really 2.3 repeating times when you subtract 9 and 8. So this is like a 9 minus 8 over here. We use purple because I did that earlier. 9 minus 8. For our exponents, this is going to get you 10 to the first power with that 9 minus 8. And that's it. It's in standard form. It's in scientific notation. This is 2.33 times 10 to the first. And in standard form, we're just moving our decimal to the right one because of that exponent. So it'd be 23.3, and really it would be repeating, but I'm all right with that. Okay? To the right. Again, I'm going to separate this out. This is really 1.14 over 4.8. I think we're going to run into an issue with this, and you'll see why in a second. Maybe not. Oh, no, we totally are. 6 over 10 to the negative sixth. Okay. 1.14 divided by 4.8. Yeah, okay. A little bit of an issue here. That's no big deal. 0.2375 times 10 to the, we have 6 minus negative 6, which is actually going to be a positive 12. The problem with this, hopefully you guys are starting to pick this up, is that our front number is not between 1 and 10. So in this case, we actually have to increase our decimal. And if we're increasing our decimal, that means we have to decrease our exponent. So they're inversely related. So this is going to be 2.375 times 10 to the 11th power. I'm just going to use a calculator to do this. It might not even let me. Nope, it's not. So let's see. It's It's going to be 2375. That's 1, 2, 3. I think it's 8 zeros. Yikes. 6, 7, 8. So large number, super large number. Okay. Again, really, it's just divide those and then make sure that your front number or your front factor is between 1 and 10. All right. So pause the video, try these next two, and then all we have is addition and subtraction. Okay, next one. Again, I'm going to separate these. And then I'm going to divide 8.37 by 2.7. That's going to give me 3.1, which is good. That means it's already going to be in scientific notation. And then I'm going to take 8 minus 3 to get 10 to the 5th power. That one was relatively harmless. So in scientific notation, 3.1 times 10 to the 5th. In standard form, it'll be 3, 1, 1, 2, 3, 4. So 310,000, looks like. Okay. And then the second one, same deal. So I'm going to separate these guys. So we've got 9 over 2.4. Oops, that should be times. 10 to the negative 11th over 10 to the 8th. Oh, I made a mistake on this one. Front number looks good. That's going to be 3.75. Second number, that exponent is going to be hilarious. So what we're going to do is we're going to take negative 11 minus 8, which gets us a negative 19. I'm going to be real with you. I'm not going to do the standard form of that one because it's going to be ridiculously long. So scientific notation will be all I do on this one. Okay. So this would be 10 to the negative 19ths. And again, standard form is going to be way, way, way too long on that. All right, but in general, that's how we do division. Okay. All right. Last step. Last things that we're going to do. Addition and subtraction. I think at this point, with the practice of moving those decimals, it's going to make things a little bit easier for addition and subtraction. So the key with this, in adding and subtracting, the exponents of 10 must be the same. Okay? They must be the same. And so then, like, in order for us to do this, we either need to change this 10 to the 4th or this 10 to the 5th. What I would recommend, and I want to say it's almost all of the time, but in order to do this, I'm going to say always add, or how do I want to do this? I'm going to say not add. How about always decrease the decimal? And the reason for that, without getting way too far into it on this set of notes here, but if you decrease the decimal, that's making the number smaller, which gives you a much smaller likelihood that you are going to get a front factor that is more than 10, which means you shouldn't normally have to do that again. Okay, so I'm going to say always decrease the decimal. What I'm going to do is, well, I should have added more to it, but always decrease the decimal to the smaller one. So we're going to take a look at this 4. I want to get that one even. So what we're going to do is decrease the decimal here, right? Want to move that back 1 because we want this exponent from 4. I'm doing a real bad job of explaining this. We want to get this up to 5. That's why we have to decrease the decimal. So move him back just 1. So this will now become 0.689 times 10 to the 5th plus 9. My colors are throwing me off right now. 9.24 times 10 to the 5th. Essentially what we did is we lined up our decimals. Do you remember back in the day when you guys learned how to add and subtract, and you if you had something like, 12 plus, I don't know, 1500, right? You wouldn't set it up like this, right? That doesn't make sense because your place values are wrong. You would set it up like this, probably, okay? That's essentially what we just did by making sure that our exponents were in the same, or we had the same exponents of 10. We essentially just lined them up. We can talk about that later, but because this video is probably already too long anyways. But once you have them set up like this, you keep your exponents, right? They're going to stay the same. And then you're just going to take that 9.24 plus the 0.689. We got lucky on this. This was close, but it gives us 9.929, which is still between 1 and 10. It's close, but it's still technically in scientific notation. So that'll give us 9.929 times 10 to the 5th for scientific notation. And then for standard form, 1, 2, 3, 1, 2. So this would be 929, 1, 2, 3, with 2 zeros. So 92,900. Okay, that was kind of a whirlwind. Let's do the next one. Subtraction works the same way. So before I start moving the decimal or anything crazy, I am going to bring my smaller exponent up to the 9 because remember, that is going to ensure that I move this guy back 2. Okay, because remember, they're inversely related. So what this is going to look like is 1.263 times 10 to the 9th minus 0.01525 also times 10 to the 9th. Okay? So I know that I'm going to keep my 10 to the 9th just because I don't know how long this is going to be. I'm going to do my subtraction with my front factors first. So 1.263 minus 0.01525. Heck yeah. So this gives me 1.24775. And then again, since I don't have to adjust that decimal, we'll keep that 10 to the 9th. Boom, just like that. In standard form, so 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, pretty long number, pretty big number, okay? Crap, I gotta finish the steps. Add or subtract the constants and keep the exponent of 10 the same. And as always, first factor has to be between 1 and 10, all right? So I'd like for you to pause this video, try the last two, and then you need to show these notes to the sub, and the sub will give you the code for your assignment on Canvas. Okay, hopefully you pause this. Let's get after it. I'm going to try to go through this quick because it's a long video already. So 8.9 times 10 to the ninth plus, since I increased by 3, I'm going to decrease by 3 here. So this will be 0.0042 times 10 to the ninth. Again, add your front numbers. Gets me 8.9042 times 10 to the ninth, because we don't have to adjust because we're already in scientific notation. Don't know why I didn't copy and paste earlier. That's okay. And this is going to be 89042. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So that's your first one. Next one, again, make sure that these guys have the same exponent. So I'm going to increase the 6 by 2, which means I decrease the decimal by 2. Zero 0.0529 times 10 to the 8th. Subtract your front number. That's definitely going to be within scientific notation. So 9.5871. Keep that 10 to the 8th because we don't have to adjust the decimal. That should be it. Scientific notation. Standard form, let's see. So it's going to be 95871. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Whew. I believe that is it. All right. Show these notes to the sub. The sub has the code, and then try to work on that assignment. If you finish with that, I do have another ClearSight practice. If you don't finish the if you start on the ClearSight practice, but you don't finish it, it's not homework. I won't put it in the homework category on the Canvas page, so don't worry about that. But that is a quick rundown of scientific notation.